Very good morning, students. I'm Vanita, Assistant Professor, Department of EEE R&D Engineering College. Now we people are going to discuss some of the concepts in digital signal processing. So in today's class, in today's session, we people are going to discuss about the periodic and aperiodic signal. So listen, dear students. A signal x of n is said to be periodic with a period n if and only if x of n plus n is equal to x of n for all n. If this condition satisfies only, we can say the given signal is a periodic signal. If the condition is not satisfied, the given signal will be an aperiodic signal. So here, the smallest value of n for which the above equation hold is known as the fundamental period. So capital N we have, right, is nothing but the fundamental period. And n value, it's nothing but, for example, we people are fixing the small n values like 0, 1, 2, 3 and so on, like that. So what is our motto? The given signal will be x of n, which is a discrete time signal. We people are in a position to say whether the given signal is a periodic signal or aperiodic signal. Now I have an example graph that how your periodic signal will look like and how your aperiodic signal will look like. I have a model graph over here. So kindly look at this graph. So x-axis is small n and y-axis is x of n. X of n is a discrete time signal. You people know very well. So kindly see over here. So whenever n value is minus 4, you are getting the x of n as 4. Whenever n value is minus 3, you are getting the x of n as 3. Whenever n value is minus 2, you are getting x of n as 2. So 4, 3, 2, 1. And see the next cycle. 4, 3, 2, 1 as output. Once again, 4, 3, 2, 1. So the output pattern will be a repeating one. So then one I can say it is a periodic. 4, 3, 2, 1, 4, 3, 2, 1. So here also 4, 3, 2, 1. Okay, the amplitude is repeating. X of n is repeating at equal intervals of time. But whenever I say aperiodic signal, it won't be like that. See over here, 4, 3, 2, 1. Here, 4, 3.5, 1.5, 2.5. The next cycle, 4, 1.7, 1.6, 1.4. So if you are getting the output like this, it is called aperiodic signal. Okay. So what is the main thing you must remember whenever we are talking about a periodic signal, at regular intervals of time, same set of amplitude must be repeating. So listen, students, we have to consider a discrete time signal first. For the discrete time signal will be x of n, that is equal to a sine omega naught n plus theta, where a is the amplitude, omega naught is the frequency shift, and the theta value is a phase shift. So a discrete time sequence is periodic if it satisfies the what condition? X of n plus n must be equal to x of n. Am I correct? So now we are going to find x of n plus n. So you have x of n over here. With this help, we are going to find x of n plus 1. So what has to be done? Wherever you have n over here, that n must be replaced by what? N plus n. So that's what I did over here. Okay. So after substituting, what I have done, just I'm expanding. A sine omega naught n plus omega naught n plus theta. Okay. So regarding this, I can say this omega naught n, this omega naught n must be equal to 2 pi m, where m is the smallest integer. From this equation, I can able to find the omega naught. Omega naught is nothing but, which is nothing but frequency shift that can be calculated by 2 pi m by n, where m is the smallest integer. One important thing you must remember is this omega naught n is an integer multiple of 2 pi. Then only we can declare the given signal as a periodic signal. Kindly make a note of this. Okay. So fundamental period n is equal to what, ma? 2 pi m by omega naught. From this equation only, I am rewriting the capital N equation. So the key point you must remember is your omega naught n is an integer multiple of 2 pi. Then only you can say the given signal is the periodic signal. If it is not satisfying, the given signal is the aperiodic signal. So listen, students. To find the n value, that is smallest value of m must be chosen. That is main important point. smallest value of n must be chosen. Okay, so that we can make we can make, that is, we can find the n value with the help of formula n is equal to 2 pi m by omega naught. Imagine your question is having two signals, say x1 of n and x2 of n. That time you have to find n1 and n2. Two n values you will be getting. You have to find the ratio between that n1 and n2. That ratio must be an rational number. That ratio must be a rational number or an integer. Then only we can say it is periodic signal. If it is not satisfying, the given signal is aperiodic. What are the key points you must remember? Small value of m value must be chosen, and if two discrete signals are given, for example x1 of n and x2 of n, you have to find the n1 and n2 values. For that n1 and n2, you have to find the ratio, and that ratio must be a rational number or an integer. Then only we can say the given signal is periodic. If it is not satisfying, the given signal is aperiodic. Now we people are going to see some of the examples related to periodic and aperiodic signal problems. So first I have an example. X of n is equal to e power j 6 pi n. So what I have to do, listen over here. So whenever x of n value is given, so first, since it is an exponential function, you expand it first. So e power j theta, it's nothing but cos theta plus j sin theta. So in that perspective only I'm expanding. Cos of 6 pi n plus j sin 6 pi n. So in this regard, which one is omega naught? 6 pi only omega naught. So omega naught is equal to 6 pi. In order to find the fundamental period, yeah, that is the formula n is equal to 2 pi m by omega naught. In this formula, you have to substitute the omega naught value here. After substituting, you are getting 2 pi m by 6 pi. So we are getting like this. Okay. So if you strike this 2 and this pi will get cancels. If you strike out this 2 and 6, you will be getting 3 in the denominator. So thereby n is equal to m by 3. So, listen students, now we are in a position to find the smallest integer value, which is m. Smallest value must be chosen, this m value must be chosen as very smallest value. Thereby, your n must become an integer. Okay, so what can be substituted? 3 can be substituted. If I am substituting 3 in the place of m, 3 and 3 get cancels with each other, thereby n equal to 1. Smallest sample has to be just substituted. Even you substitute 6 also, you will be getting n as integer. But what is the criteria we have? M must be a smallest integer value we have to substitute. Since we have to substitute m as a smallest value, I am substituting m value as 3. So here n value I am getting integer. So the signal is said to be periodic with a time period 1. So like this, we have to do the periodic and aperiodic signal type of problems. So the given signal is a discrete time signal. We have to declare whether it is a periodic signal or a aperiodic signal. Now I have one more example, students. Listen over here. So here I have x of n as cos of 2 pi n. So in this problem, which is omega naught, 2 pi is omega naught. The 2 pi I'm substituting in the place of omega naught. Okay. So after substituting, I'm getting n value as what, ma? I'm getting n value as n. So now I am going to fix the m value. Thereby, I can make n as an integer. So simply, I can substitute m as 1, 2, 3, 4, 5. Any values I can substitute. But what is the criteria we have? Minimum value of m has to be substituted. So I'm taking m value as 2. Thereby, I'm making n value as 1. Since I'm getting n value as an integer, the signal is periodic. Now I'm going to say one more problem to say how to find the aperiodic. Let's see. X of n is equal to 12 cos of 20n. This is the third question we have over here. So in this question, which is omega naught, 20 is omega naught. So this omega naught has to be substituted in your n expression, that is 2 pi m by omega naught. So here in the place of omega naught, I'm going to substitute 20. So see over here, I'm getting m pi by 10. So see over here, students, here Whatever the values of m you can put, you cannot make n as an integer because you have pi. Pi, what is the value of pi? This 3.14. So whatever the value of m can be chosen, you cannot make n value as an integer. So the signal is aperiodic. So in this session, we have understood how to find whether the given signal is periodic or aperiodic. Thank you.